In this video, I am going to show how to draw the triiodide ion. I will draw the Lewis dot structure and the VESPR structure. To draw the Lewis dot structure of triiodide ion, I need to determine how many valence electrons and electron pairs there are. Iodine has 7 valence electrons. So for the ion, the total number of valence electrons is, I have 3 atoms of the iodine ion atom at 7 valence electrons each, plus for the negative charge, there's 1 extra electron. So that's a total of 22 electrons. Total number of pairs of electrons is 22 divided by 2, which gives me 11 electron pairs. So now we'll draw the Lewis dot structure for the triiodide ion. There are 3 atoms of iodine. And then we'll each have a bond. From the previous slide, we know there are 11 electron pairs. So we have 2 pairs already done in the bonds. 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8 pairs there. And the remaining 3 pairs will go around the central atom. So that is the Lewis dot structure for the triiodide ion. The only thing we need to add are the brackets and the negative charge. Before we can draw the VESPR structure, we need to determine what type of structure we have, and that is found by counting the number of bonding pairs we have between atoms and lone pairs. So bonding pairs we have between atoms, we have 1, 2, and lone pairs we have 1, 2, 3. So the total number of pairs that we have is 5. which makes this structure, when we draw it as a VESPR structure, a trigonal bipyramidal, and in that form, because we have 2 bonding pairs and 3 lone pairs, it would be linear. For the triiodide ion, the VESPR structure is very easy to draw, as it resembles the Lewis dot structure almost exactly. So we have our iodine atoms, we have the bonds between them, and the other electrons. And in this, for the VESPR structure, we would need to show the angle between the bonding pairs, and that angle, because it is linear, is 180 degrees. And then we just need to show the charge. And that is the VESPR structure for iodine or triiodide ion. This is a rendering of the triiodide ion using the moles app. The only thing missing out of this are the 3 lone pairs of electrons that would be found around the central iodine atom. In this rendering, using a different app, you can see, this is using the VESPR app, you can see the 3 pairs of using the VESPR app, you can see the 3 lone pairs of electrons around the central atom. In this 3D model that I created, you can see the 3 iodine atoms in a linear form, straight across from each other. And these are the 3 lone pairs of electrons surrounding the central atom in a plane of its own. And that's why you have the octahedral shape, because the 3 lone pairs technically are a plane equatorially around the central atom.